Okay, so we are in section 10.1 looking at chi-square test of independence and homogeneity. And so I want to look at an example. This is page 635 in the text, problem number 10. And so it's on the table of the personality preference type. Performances or preferences for a random sample of 519 people. That's my sample size in the listed professions. You can see the professions here. T refers to thinking, F refers to feeling. So did they identify more as thinking people or feeling? So for example, clergy in all denominations, most of them think of themselves as feeling and others as thinking, right? Now, compare this to the table down here. This does not have expected values, so we're going to have to calculate those ourselves. I'm going to show you the first one and then you can do the rest. So you can see that the thinking column, these three right here under T, that's under my first observed column, right? So that's all of those observed from that sample. The column total is here at the bottom, 252. For my feeling, that's in the second observed column over here. And you can see it has the total of 267. And again, what we're missing is the expected column because chi-squared depends on doing observed minus expected. And so for the thinking column, these are my expected values. And let me show you how we get those. It's in your notes and I'm in the wrong place. So we have to find the observed value minus the expected value. And the expected is the row total times the column total divided by sample size. So let's get the calculator up here and you can see how I'm going to calculate that. So for this, well, let me just go on and go down here to this one. Well, no, I'm sorry. Let me go back to the previous one. That might make more sense for you. All right. So for this first number 57, the clergy that are thinking, here's our formula. Row total times column total divided by sample size. The row total is 148. That's the total, of course, going across the row. The column total going down is 252. And you're dividing by the sample size, which is 519 is the size of our sample. Right, now this is the expected value, right? 71.86 and it goes on there. So check this out. Here's my first expected value, 71.9. All right, I rounded to the 10th place. So then you would go on and find the rest of these expected values using the methods that I've just done. You know, it's your observed value times the respective row total. The column total times the row total divided by the sample size, which was 519. So you would go on and populate the rest of those. So then we're going to get this table down here at the bottom that you see. So here's what we got to do with this. We're going to do this entirely on the graphing calculator rather than by hand in tabular form. So to do this, we need to put some stuff in matrices. We want the observed values in matrices or in a matrix and the expected values in a matrix. And then we're going to do a chi-squared test on it. And I'll show you that. So first, let's go into second matrix. Arrow over to edit. Now for our purposes, matrix A is going to be the observed values. Matrix B is going to be the expected values. So we'll go on and press edit. Now I've already done this beforehand to make sure I knew what I was doing. Notice if I do my observed values, 57, 77, 118, 91, 82, 94, I have a matrix that has 3 rows by 2 columns. So you want to make sure you set your rows and your columns times the size of your matrix. So this is a 3 by 2 matrix. Okay. So I've entered all of that data in matrix A. Now I'll go back into second matrix and we would edit, go to number 2, which is matrix B. And now I entered the expected values. Now, these expected values I got from the graphing calculator. So they're, here I rounded off. So there's be a little bit of error if you use like what's on this table right here. So here's my other 3 by 2 matrix with matrix B. My 71.9, it's 71.864, 77.2, that's the 77.2, all the way to this 109.6, which I rounded here to 109.1. All right, so then we would, after we enter all of that, we'll do second quit again. Now we're going to go into stat tests. And we want, you could either go up or down. Here it is. It might be closer to going up. We want option C. This is the test of independence and homogeneity. Option D, by the way, this is 10.2, which we are not going to have time to cover 10.2. It's called a goodness of fit test, but it's done similarly with observed minus expected values. Anyway, we're going to do this. The default is your observed values are in matrix A and your expected values are in matrix B. Okay, so let's calculate and see what that p-value is. 0.005 is the p-value for this. Okay, so let's go back to, please let me still have them. We're doing this at a 1% level of significance. So based on this information that we found, it is significant. You would reject the null hypothesis. The null hypothesis is one of independence for this stuff. In fact, let's go up here. So if the p-value is less than or equal to the alpha value, your level of significance, you'll reject the null hypothesis as usual. That means the variables are not independent. That means there are some dependence going on there. If it's greater than or equal to, we do not reject the null hypothesis. The variables are independent. So your null hypothesis is that they are independent of each other. Remember that, okay? And again, you have homework out of here that you can look over and try it out on the graphing calculator. And again, you're doing the chi-square test.